So my research field is the field of particle physics. And in particular, within particle physics, I studied the Higgs boson, which is the most recent addition to the field of particle physics and the most recent addition to the standard model, which is the model for describing particle physics. I am an experimentalist, which means that I try to create it in a lab setting. In this case, the Large Hadron Collider, the LHC, near CERN in Geneva, and the particular particle detector, Atlas detector. And so I was part of the Atlas collaboration. So the Higgs boson, similarly to what many people already know for, let's say, nuclear particles like uranium and things like that, the Higgs boson also decays. And this is what we call the lifetime. So this is relevant because, I mean, we've only recently, let's say a bit more than a decade ago, found this particle in the first place. And now we really want to characterize it. So we really want to understand if it is really the particle that we expect it to be. And the lifetime is one of the main properties of this particle. This is a particularly relevant property as well, because if it has a shorter lifetime than we expect, or equivalently, if it decays faster than we expect, this might indicate that it also decays into new undiscovered particles that we don't know about yet. And so this could actually directly give us some kind of hint towards there being new physics. Actually, measuring the lifetime of the Higgs boson is a very difficult task to do. The Higgs boson is expected to live only 10 to the minus 22 seconds, so it lives extremely briefly. And so measuring this lifetime directly is actually pretty much impossible with our current experimental setup. So what we have done in this research instead is to rely on the work of some theorists using so-called off-shell Higgs bosons in a state that's not real. And we can somehow use these virtual Higgs bosons to also tell us something about the lifetime. So we actually, at the end of this research, found a lifetime for the Higgs boson, 7.3 plus 86.7 minus 5.7 times 10 to the minus 22 seconds, still compatible with what we expect based on the standard model. In order to really be able to say if there is new physics in the Higgs boson, we would need more precise measurements. And this could come from more statistics. So what that means is more collision events. In the near future, the high luminosity Large Hadron Collider is planned to start. There we can perhaps find if the Higgs boson does hold some new physics that we don't know about yet.